Hello children. In this video, I'm going to explain exercise 1.4, question number 1 in this fifth bit. For the previous 4 bits, I have explained in a different video. Please check my previous videos. Okay. This is giving a proof for the irrational numbers. The fifth bit is 3 plus 2 root 5. Let us take on the board 3 plus 2 root 5. 3 is a rational, 2 root 5 is irrational number. So we are going to prove a rational and an irrational is a irrational number. You know already, it may not be irrational always, right? Okay, sometimes it may be a rational also. But here we are proving that this given number is a irrational number. So let us assume the contradiction. The given number is a rational number. Okay. Let us assume that 3 plus 2 root 5 is a rational number. So we know that rational number is in the form of p by q. So take 3 plus 2 root 5 is equal to p by q. Let's define what is this p by q. P and q are belongs to P and Q are belongs to integers, and the denominator should not be equal to 0, and also P and Q are co-primes. They're having HCF as a 1. Okay. Now we will isolate this irrational part and let's take the remaining part to the other side by Q minus 3. Okay. Now what we have to do, we need to do the squaring on both sides, right? We can do the squaring on both sides. So here, actually, let's take 2 root 5 is equal to, the LCM is first Q. P minus Q times, this is 3Q. Okay, this is already rational part we got. So we will isolate this irrational number. 2 we will bring this side. Here it is multiplication. It will become a division. 2Q. In the denominator it comes. Observe this. P and Q are, P and 3Q are integers. When you subtract these two integers, you will get an integer only as a result, right? And here 2Q is also an integer. So when both the integers are get divided, you get a rational number. But this root 5 is an irrational number. Okay. So root 5 is an irrational number. We know irrational number. And P minus 3Q by 2Q is a rational number. Okay. Are they can be equal? No. An irrational number can't be equal to the rational number. So this is contradiction to our assumption. This is contradiction to our assumption. Therefore, root 5 is, and no, they have a given 3 plus root 5, 6 plus root 5, root 5, 3 plus 2 root 5. 3 plus 2 root 5 is an irrational number. 3 plus 2 root 5 is an irrational number. Give your steps very perfect. It's 4-mark question. Okay. Let's see. Next question. Prove that root p plus root q is an irrational where p comma q are primes. Where p comma q are primes. They told. Question number 2. Root p plus root q is an irrational. So let's take the contradiction. Let us assume these both are rational. Let us assume root p plus root q is a rational number. So if the rational number it is, then it will be p by q form. Already p and q are used. Let us take a different variables a by b form. Okay, now is equal to a by b form to avoid the confusions. Same definition. A and a comma b belongs to integer family. In the denominator, it should not be equal to 0. A comma b are co-primes having a HCF as a 1. Right. Now, isolate any one of the rational towards to the left side and transpose the rest of the thing to the other side. Here, both are irrational numbers. So, anything you can keep here. I am keeping root p and taking this root q. A by b minus root q. Now, both side we have a roots, right? So, we will do squaring on both sides. ds means both sides. So we get root p whole square is equal to a by b minus root q whole square. Square and root get cancelled. P is equal to, this is like a minus b whole square, where the formula is a square plus b square minus 2ab. So a square by b square plus b square root q whole square minus 2ab, 2 into a by b into root q. Now, p is equal to a square by b square. Square and root get cancelled. It's plus q minus, which is nothing but 2 root q a by b. See, this is a rational, this is a rational, this is a rational. But here we have a irrational number. Okay, so let's take this whole term to the other side, left side, and bring this to the right side. So this negative will become positive. 2 root q a by b is equal to same thing as it is, this as it is, a square by b square plus q. Okay, this also p as it is. This we bought this side. So nothing is mentioned here. LCM is b square, right? So a square plus b square is LCM means qb square. Multiply with b square. Okay. Yeah. Now what we can do here? Bring this p also other side. 2 root q a by b. So here plus p becomes minus p. So for this also we'll take LCM. LCM is b square. A square plus qb square. So b square is LCM. B square p. 2 root q a by b. Now, root q isolate because it is the irrational, and rest all the things you bring here, b square is common. Bring other side. So here it is with root q, 2 and a by b are multiplication. If we bring other side, it's a division. So we will reciprocate this. Division means we will write b by 2a. 1b get cancelled. Now nothing else get cancelled. Root q is equal to a square plus b square of q minus p divided by b into 2a, 2ab. See here, this a square b plus b square times of q minus p is integer. And this 2ab also integer. So if we divide two integers, we get a rational number. But here root q is an irrational number, which can't be equal. So let's write root q is an irrational and a square plus b square times of q minus p divided by 2ab is a rational number. So, so this if an irrational can't be equal to the rational. So this is contradiction to our assumption. This is contradiction to our assumption. Therefore, root p plus root q is an irrational number. Hence proved. So this is how we can end up the exercise. See, whenever a single term is there, whenever you take a p by q, you have to do just transposing, squaring on both sides, and you can prove it. Here also two terms are there. Take one term to the other side and do the squaring on both sides, and we can prove. Here even two terms are there. Keep the irrational term on left side, take the rest of the thing other side and do the squaring on both sides. Same this one also, same this one also. So this is how we can prove. Thanks for watching my videos. Keep watching for the more number of questions. Bye bye.